Hello everyone, welcome to another Python tutorial series. This is the last episode of this tutorial series, and in the previous two videos, we set up the background, brought in the obstacles and the dinosaur, and created collisions. So in this video, I'm going to deploy the AI to the game so that the player will learn from its mistakes and harness its skills to become better at the game. So before we start, let's run the game to see what we have so far. If I run this, we can see that this cacti is moving towards, or this dinosaur is moving towards the cacti of different sizes and types. So whenever the dinosaur collides with the cactus, a green box appears around the dinosaur, and that just means that we set up the collision detection correctly. But if we also hit the space key, we can make the dinosaur jump over the cacti. So we'll need a configuration text file for the neat Python simulation, and I've already created one in my working directory, so let me open this file. So if I open it, I go to where this file is located, and I have a config file right here. So the config file is a text file that contains all the details of how the network will be trained. You can specify all the essentials in here, and I'm not going to go into details of all the parameters in this file, and if you'd like, you can go to the neat Python official website for more information. So it has detailed descriptions of each parameter in the config file, and if you don't understand them all, that's okay. I do want to highlight some parameters though that are essential or unique to this game. So if we look at line 3, the fitness threshold, this just represents the number that we decide, and once the fitness exceeds this number, we're going to terminate the program. Now if we look at the population size, this defines the number of dinosaurs at the beginning of each generation, and generally speaking, the larger the population size, the less generations will be needed for the network to train itself. So if we go to line 48, which is just the number of input parameters or output nodes, the network basically receives inputs through nodes, and the two parameters in this game are the y positions of the dinosaur and the distances between the dinosaurs and the cactus ahead of them. So if we go to line 49, the output nodes, then the network delivers outputs through output nodes. And the two outputs in this game are going to be jump or not to jump for the dinosaur. And so the neural network will determine whether the dinosaurs should jump or not based on the two input nodes and train itself to get better at the game. So let me close this config file now. I'll close this. And so when the AI is implemented, the game will be played by itself. So no key will be needed to be pressed by us. So let's get rid of this of the piece of code where we check for the space key. So let's go to our dinosaur class. So class dinosaur. And here I'm checking the key state. So what I could do is remove this. So remove this if and else if statement. And we also need to delete the part where we draw our green rectangle. So that's also, or that's in our game loop. So inside of our game loop, we check if dinosaur.rect.collideRect with our obstacle rect, then we create our green box. So what I'm going to do is delete this. So we'll make sure that no green box will be drawn around the dinosaurs. And also in the simulation, we're going to have multiple dinosaurs in each generation. So instead of creating one dinosaur object, we're going to create multiple. So at the top of our game loop, we have our obstacles. First of all, I'm going to delete this dinosaur object and have dinosaurs equal to an empty list. So now since we have multiple dinosaurs, we will move and draw each of them with a for loop. So still inside our game loop, what I could do is iterate through our dinosaurs. So for dinosaur and dinosaurs, I will move each dinosaur. So actually, we have this code right here. So dinosaur.move and dinosaur.draw. So I'll copy this and move it inside this for loop up here. And now we will load the config file and do some network setup. So instead of running the game loop here, delete this. I'm going to have a neat config variable equal to neat.config neat.default genome neat.default reproduction, and then neat.default species set, and neat.default stagnation with our config.txt. So I'll have set population equal to neat.population with our neat config. I'll set the stats equal to neat.statistics reporter. I'll add to the population our reporter of stats, and this will give us our statistics report for each generation. And we will run, so population.run with the game loop, and the second parameter will be 50. So we're going to call the game loop function to run the game, and here 50 is the maximum number of generations allowed for the AI game. So in this AI game, the game loop is the fitness function, and what it does is that it will compute a single real number to indicate the quality of an individual genome, and the better ability to solve the problem will have a higher merit score. So in this fitness function, we'll need to add two parameters, the genomes and config. And config is a file that we just loaded, and the fitness function will evaluate each of the genomes. So when we define our game loop, I'm going to pass in two variables, two parameters, so genomes and config. So now we can create two lists in the fitness function. I'll call one GE, it's going to be an empty list, and nets is equal to another empty list. So nets will be used to keep track of the neural network that controls the movement of each dinosaur, and GE will be used to track the genomes so that the fitness can be changed based on the scores the dinosaurs get. So now we'll loop through the genomes to create the dinosaurs, get the nets and GE values, and the initial fitness value for each genome will be set to 0. So what I'll do is iterate, so for blank genome and genomes, I will append, so dinosaurs.append, a new dinosaur object, and inside the GE list, I'll append the genome. Now I'll set net equal to neat.nn.feed forward network.create genome and config. Nets.append, I'll append our net, and genome.fitness, I'll set the fitness equal to 0. So we still need collision detection because we'll use it to see how the network is doing and change the fitness score for each dinosaur based on its performance. So still in our game loop, we want to check, while we're iterating through our obstacles, we want to check or iterate, so for I, dinosaur, and enumerate dinosaurs, we want to see if dinosaur.rect.collide rect. So if the dinosaur collides with an obstacle.rect, then we'll set GE index I.fitness and decrease it by 1. Since we clutter something, we'll remove that dinosaur from our dinosaurs list. ge.pop_I and next.pop_I as well. So because we have multiple dinosaurs, we'll loop through the lists, and whenever there's a collision, the fitness score will decrease by 1. We will remove the dinosaur, the genome, and the net from the list. So now we'll feed the inputs and activate the neural network. So if we go back, and this is going to be for the activation for I dinosaur and enumerate dinosaurs. We'll set our output equal to nets index I.activate dinosaur.rect.y obstacle.rect.x minus dinosaur.rect.x. We want to check if the output of index 0 is greater than 0.5 and dinosaur.rect.y is equal to dinosaur.initial y. Then we'll set dinosaur.jump equal to true. And dinosaur.run equal to false. So here the two input parameters used to activate the network are the y position of the dinosaur and the horizontal distances between the dinosaurs and the cactus ahead of them. So also we will need to add a condition to determine when the simulation will go to the next generation. So what we could just do is check if the length of our dinosaurs list is 0, then we can return. So basically when there are no more dinosaurs alive, we will move on to the next generation. So if I save and run this, we'll see that the network should be working. So right now we have multiple dinosaurs, and they're learning, and so this is basically one of the last dinosaurs remaining, and it's learned based on the other dinosaurs who are dead, and now it's able to jump over these cacti with no problem. But it'll be nice to have some stats shown onto the screen, such as how many dinosaurs are still alive, what generation we are in, and what the current moving speed is. So what I'll do is create a bunch of statistics and show them onto the screen. So right after this, I'll set text 1 equal to font dot render. I'll use an f string here. Dinosaurs alive. String length. Dinosaurs. I'll end the f string. So like this. I'll pass in true and black. See dinosaurs alive. Now I have text 2 equal to font.render, another f string, a generation, and this is going to be the population, generation plus 1. True black. Text 3 is equal to font.render, game speed. I'll convert the string, the move speed, to true black. Onto the window, I'll blit out text 1 at the location 650. I'll blit out text 2 at 680. And I'll blit out text 3 at 600, 110. So if I save and run this again, now we have the information of the number of dinosaurs alive, the generation, and the game speed. So now we'll add our scoreboard. And if I go back, at the beginning of our game loop, I'll set our score variable equal to 0. And the score will increase 1 for each frame, and whenever the score is a multiple of 100, the moving speed will increase by 1. So the dinosaurs will move faster and faster as long as they're alive. So right after where we create our statistics, we'll have our score. So score plus equal to 1. If score mod 100 is equal to 0, then we'll set move speed and increase it by 1. We'll set text equal to font.render. The score string score true black. Then we will put onto the screen our score at 620. So now if I run this, we will see the scoreboard with increasing scores. And when the score gets bigger, the dinosaur will be moving faster. So now we're on generation 4, 5, 6, and it looks like the AI is having a little trouble learning in this generation. So if I try to replay this, now it looks like this time is learning a little bit better. It's in generation 3. And as the score keeps increasing, this will get faster and even more difficult for our dinosaurs. So sometimes people would like to add lines to connect our objects, or basically to just connect the objects together, and we could do this as well. So we need to modify the draw method in the dinosaur class a little bit. So I'll close this for now. And inside the draw method of our dinosaur class, I'll go up right here. I'll iterate through our obstacles. So for obstacle and obstacles, I will draw our line, pygame.draw.line, the window, green self.rect.x plus 54, self.rect.y plus 11, and obstacle dot rect dot center, and a parameter of 2. So now let's add one more parameter when we call the draw method. So in our game loop, when we call dinosaur.draw, which should be right here, instead of just having the window, I'll pass in obstacles as well. So when we run, if we look at this, dinosaur.draw, draw takes 2 positional arguments, but 3 were given. If we go back to our draw method, we also need to pass in obstacles up here. So if I save and run this now we see that each dinosaur has like a line connecting to the nearest obstacle. Now this is still generation 1, but the set is doing really well. So this is the end of this video, and also this series. If you have any comments, please put them below at the comment section. If you have not subscribed to the channel, please hit the subscribe button below. Thank you for watching, and I'll see you guys next time.